Okay, so for today's lesson, we're going to be graphing secant and cosecant. So there is a warm-up here, and it's asking you to graph the following two trig functions, a cosine function and a sine function. So I want you to pause the video in a minute and do this warm-up yourself. I'm going to jump straight to the graphs with the domain line all completed and everything. So the only thing I want you to do is after you plot the points, stop. Because the way we graph cosine and sine, the beginning part of it, the way we graph secant and cosecant, the beginning part and how we set up our characteristics is just like as if it was a cosine or a sine graph. So I want you to see that connection. So take a second and pause this video and complete these two graphs. Okay, welcome back. I hope you have done that. I am going to take those two functions. So like I said, it's 4-5, graphing secant and cosecant if you want to title your notes. And then this was the first warm-up question. It was y equals 2 cos 2 pi x plus 1. All that I did here was change the cosine to secant. Those are reciprocal trig functions. So here's how your domain line should look. Your vertical shift and your amplitude lines. I am going to put the points in, which you should already have on your graph. So there was no vertical shift, so there was no horizontal shift, so our starting point was at 0. Cosine graphs, we know start at the top or the bottom. It's going to start at the top since it did not reflect down. And so then our points follow this pattern like so. Okay, so if this was a cosine graph, we would just connect those points and make our wave. When we evaluate secant and cosecant, there are parts where they are undefined. So that is when we get the 0 on the denominator. So what is happening here? When is this function undefined? Well, anytime you have a point on the middle dashed line, that is a time that that function is undefined. So we have to place vertical asymptotes. So anytime we have a point on the middle dashed line, and this is true for secant and cosecant graphs, I put these vertical asymptotes, and we'll talk about writing the equations of these on the last two examples. The points on the top and bottom amplitude lines are going to be have parabolas. So I'm going to do the two end ones in a second, but if the points on the bottom line, you have a parabola facing downward, and then on the top facing upward, and then this one is down. Okay. We're graphing over 2 periods. So for this one right here, we're not going to make a complete parabola. We only want that left piece. And this point over here, we only want that right piece. You should have a total of 4 parabolas graphed. So those 2 halves will make that 4th. And there is the secant graph. I'm going to move on and do the same thing with that second example from the warm-up. This one we had to we were going to rewrite it as cosecant, but we also did some simplifying here. So we had to GCF out that -3, and then it moved out front. If we remember that sine graphs have their odd functions, they have origin symmetry. So an x-axis reflection is going to be the same as a y-axis reflection. So we moved that out front. So this is our simplified equation. Our starting point is at the pi over 5, and sine starts in the middle. Okay, and then as we graph to the right, depending on this sign right here, the sign out front, if it's positive, we go up. If it's negative, we go down. So we're going to be going down since that's negative, then middle, top, middle. We don't have a point on our y-axis, like we don't place a point there because we didn't have a tick mark there. But there's how your point should fall. Just like we did with our cosecant graph, if you have a point on the middle dashed line, you're going to have an asymptote there because that is where that function is undefined. So we place our vertical asymptotes, and then let's place our parabolas. So this one is going to be 4 whole parabolas. It all depends on how everything falls. Awesome. So there is example number 2. Okay, y'all write down example number 3, and I want to encourage you to stop the video and try this one yourself. Simplify it and see if you can get it graphed. I'm going to jump straight into it. We have to GCF out that -6. So I'm going to put the x forward. If we're dividing by -6, that's the same thing as multiplying by -1/6. So it's going to leave you, when you multiply that pi over 2 by -1/6, you get minus pi over 12. And what I like to think about is if I were to distribute that -6 back in, would it simplify down to pi over 2? And yes, it would. That negative sign with our b, we need to deal with that. Since this is like cosine, cosine is an even function, which means a y-axis, that's going to be a y-axis reflection, and that's not going to do anything. So we get to just drop that negative sign. It's not going to change our graph. And that's the equation that we are going to be graphing. So we start with our horizontal shift, and that's in the positive direction, pi over 12. So I'm going to circle my starting point. I'm going to do 4 tick marks in either direction. The period of this graph is 2 pi over our b value, which our b value is 6. That simplifies to pi over 3. This helps me find my quarter periods. 1/4 of pi over 3 is pi over 12. So I'm adding and subtracting pi over 12 to get my domain line, my x-axis. So pi over 12 plus pi over 12 is 2 pi over 12, which simplifies to pi over 6. This is 3 pi over 12, which simplifies to pi over 4. 4 pi over 12, which is pi over 3. And then this is 5 pi over 12. Moving to the left, pi over 12 minus pi over 12 is 0. And then this is negative pi over 12. Negative 2 pi over 12, which simplifies to pi over 6, and negative 3 pi over 12, which simplifies to negative pi over 4. Our vertical shift is that constant at the end, so we're down 2. So now I can go ahead and place my y-axis. I'm going to put my dashed lines. I'm down 2. You have to tick mark off your y-axis as well. I need to clearly see that you went down 2. The amplitude is 3, and we are going, there's that negative, so which means this graph has been reflected. So amplitude is always positive, but we'll use the negative as far as how we start. Okay, so there are 3 dashed lines. So let's go to our starting point. Cosine always starts at the top, but since it's been reflected because of this negative sign out front, we're starting at the bottom. And then middle, top, middle, bottom. And then middle, top, middle, bottom. Awesome. Okay, so just like we did before, if we have anything on the middle dash line, it gets an asymptote. And then points on the top and bottom line get parabolas. If you have ones at the end like this, remember we just want half of a parabola. And it's going to be the half closest to the graph. It's like you just snippeted a picture of the graph. So make sure it's the ones on the inside. Okay, so moving on from this, we're going to talk about writing the equations of asymptotes. So we just talked about how we place these asymptotes. They're vertical lines, so we're just going to write equations for any asymptote in the graph. So here's what we need to do. We have to simplify the equation first. We're not going to fully graph this. We're just going to graph as much as we need to. So I'm going to GCF out a negative sign here. And then since it's a sine, that's going to move out front and make it positive. So here's my simplified equation. Okay, the vertical shift and the amplitude do nothing for the asymptotes. That's not going to change where they fall. What affects it is going to be your horizontal shift and then the period and quarter period. So my horizontal shift is at negative pi over 4. So I'm just going to sketch a little domain line here. So that's negative pi over 4. That's my starting point. And then the period for this graph is going to be pi, because 2 pi divided by 2. So quarter period is pi over 4. So that's what we're adding to get from tick mark to tick mark. So I'm just going to do a few. I like to get in and around 0. So if I add pi over 4, I'm at 0. And then if I add it again, I'm at pi over 4. So let's think about this. Cosecant starts in the middle. Remember, anytime you have a point in the middle, you have an asymptote. And then since it's positive, we'll have a point up here, and then we have an asymptote. So what we need is we need an asymptote to have our starting point, and then we need to know the distance between these asymptotes. So I always pick the asymptote. If it's at 0, I always pick that one, or the first one to the right of it. So I'm going to pick this asymptote right here. You have to write x equals, because these are vertical lines. So I write x equals pi over 4. That's my starting point. And then we have to add the distance between the asymptotes. So the distance between this is 2 pi over 4, which simplifies to pi over 2. So between every asymptote, we have a distance of pi over 2. We put a k there to symbolize any integer. So k will represent any integer. You can plug in anything there and simplify this, and you will find an asymptote on this graph. So again, you pick an asymptote to start at. I always pick the first one to the right of 0, and then this is the distance between the two asymptotes. Okay, let's try one more. So for this one, I'm going to go ahead and simplify this. Okay, so for this one, again, we care about the horizontal shift, the period, and the quarter period. So I start at pi over 6. The period is 2 pi over 4, which is really pi over 2. 1/4 of that is pi over 8. This has to match with that, so we have to get common denominators, so we're thinking 24. So that's really 3 pi over 24, and that's really 4 pi over 24. Okay, so I'm moving to the left because I want to get to 0. So if I subtract 3 pi over 24, I'm at pi over 24. And then if I subtract it again, or I could go the other way, I'm at, because I know zeros, we're going to pass 0 here, but I'm at negative 3 pi over 24, which is really negative pi over 8. Okay, so this is a secant graph, which means we start at the top or the bottom, and this was my starting point. So here we're going to start at the top, and then it goes asymptote. Then it goes down. So I'm actually going to find this one because I got to find the distance between the asymptotes. So if I add 3 pi over 24 to 4 pi over 24, I'm at 7 pi over 24. So I can generate that other asymptote because I got to find the distance. Okay, so we write x equals. I always pick the first asymptote to the right of 0. So I'm starting with pi over 24. And then plus this distance is 6 pi over 24, which simplifies to pi over 4. So we're going to say pi over 4, and don't forget that k. Don't forget x equals either. That's how we determine that it's a vertical line. Okay, awesome job. Y'all go head over and do the homework now.